Hi guys, today we're going to do walking through all the steps involved in generating ATP, NADH, or FADH2 and get the total of how many ATP are produced or formed. So to start, we're going to start with glucose converting into pyruvate, which happens through glycolysis. So glucose oxidation occurs in the cytosol, and then glycolysis yields 2 NADH and 2 ATP and 2 molecules of pyruvate. From here, we're going to go through gluconeogenesis. So we're going to have the pyruvate oxidation occurs in the cytoplasm, and pyruvate oxidation produces 2 acetyl-CoA enzymes. From here, the acetyl-CoA is going to enter into the Krebs cycle, which is in the mitochondria, and from here, we're going to yield 8 NADH, 2 FADH2, and 2 ATP. NADH and FADH2 enter the electron transport chain in the mitochondria for ATP synthesis. The complex 1 is going to receive the electron from the NADH. Complex 2 will receive the electron from FADH2, and electrons are transferred from complex 2 and 1 to complex 3. In complex 3, they transfers the electrons to complex 4. So, during electron transfer, proton are pumped from the matrix to the intermembrane space. The proton gradient develops, which generates the proton motive force and helps in ATP synthesis. So, with all of this, we're going to have 4 protons, which will give rise to 1 ATP. 1 NADH will produce 2.5 ATP molecules. 1 FADH2 is going to produce 1.5 ATP molecules. So throughout this whole process, we're going to have 10 of the NADH. So 2.5 times 10. Quick math. So 10 NADH will give us 2.5 ATP each. We're going to have 2 FADH2s, which each of those produce 1.5 ATP, so that will give us 3. And then 2 actual ATP molecules are produced. So adding this all up, it'll give us the grand total of 30 ATP molecules that have been produced from this cycle.